Welcome to The Explainer. Today, we're diving into a really cool algorithm that's changing the game when it comes to finding hidden patterns inside the total chaos of modern data.
So let's kick things off with a puzzle that scientists, engineers, all the big tech companies, they all face this every single day. How do you make sense of these huge, messy piles of information? Okay, imagine someone hands you this, just a sea of data points, thousands of them, like the dots you're seeing here, and your job is to find the hidden structure, to sort them into meaningful groups, or what data scientists call clusters.
Now, you and I can probably see the two intertwined spirals pretty easily. But for a computer, that's a whole other story. How do you actually teach a machine to see that pattern, especially when real-world data is way more complicated with groups of all different shapes, sizes, and densities?
This is exactly where data clustering algorithms are supposed to come in and help. But honestly, a lot of the traditional methods just can't handle the messy, beautiful reality of the data we have today.
Yeah. See, they're often built on really simple assumptions, so they get completely thrown for a loop by weirdly shaped groups, like our spirals. They also get confused when some clusters are dense and others are spread out, or by those random noisy data points, the outliers, that don't really belong anywhere.
And this is a perfect example of what I'm talking about. On the left, that's the real, meaningful grouping in the data, the ground truth. But now look at the right. That's what happens when a really popular algorithm, k-means plus plus, takes a crack at it. It just chops the data into these simple blobs and completely misses the real structure. It's not even close.
So clearly we need a better tool for this. And that brings us to the hero of our story today, a really powerful and clever algorithm called DenMune. So to put it simply, DenMune was basically built from the ground up to solve the exact problems we just looked at. It's specifically designed to automatically find those tricky shapes and deal with different densities, all while intelligently ignoring the noise.
Okay, so how does DenMune actually think? What's its secret sauce for cutting through all this chaos? Well, the core strategy is actually pretty intuitive when you break it down.
It all starts by looking for what it calls mutual nearest neighbors. A great way to think about this is like finding mutual best friends in a crowd. If point A's closest neighbor is point B and point B's closest neighbor is point A, well, they have a really strong, stable connection. This is such a smarter way to do it than just looking at distance, because it finds the true, dense heart of a group.
And this whole best friends idea is the absolute key. DenMune uses it to give every single data point one of three roles. It's either a leader, a follower, or a loner.
First up, it finds the leaders. These are the points that have a ton of these mutual best friends. They're the dense, confident core of each potential cluster. You can think of them like seeds from which the full groups are going to grow.
Next, it checks out the rest of the points, the followers. Now, these points might not be in that super dense core, but they're definitely close to one of the leader groups. So DenMune really smartly assigns them to their nearest group, which lets the clusters expand outward and take on their true natural shape. And finally, any points that are left over, the ones that don't have a strong connection to any group, they get classified as loners, or just plain noise. And instead of trying to force them into a group where they don't belong, DenMune just sets them aside. And this one little step cleans up the final result beautifully.
So that's the elegant theory behind it. But does it actually work in the real world? Well, let's find out. Let's put DenMune in a head-to-head showdown against 9 other algorithms on some famously difficult datasets.
Remember that spiral puzzle from the beginning? Okay, on the left, you see k-means plus plus just completely failing to see the pattern. But look on the right. DenMune absolutely nails it, perfectly identifying both spirals. It's a flawless victory.
And here's another really tough one. You've got all these different shapes, densities, and sizes mixed together. On the left, another popular algorithm just gets totally confused and starts mashing different groups together. And on the right, DenMune, once again, cleanly separates every single one.
And this wasn't just a lucky break. The researchers behind DenMune tested it like crazy, and their conclusion was crystal clear. They say it right in their paper. It consistently outperformed the competition on the vast majority of these challenges.
Which brings us to the final scoreboard. After running all the tests and all the comparisons, the researchers put together a definitive ranking. And as you can see, DenMune is sitting right there at the top, ranked number 1, well ahead of the rest of the pack.
This is more than just some interesting academic competition. Having a tool that actually works this well has huge real-world implications for how we discover new things from our data.
So here's the bottom line. A robust, automatic algorithm like DenMune means we can get way more reliable insights from unbelievably complex data. I mean, think about identifying different patient groups in medical research, or finding hidden customer segments for a business, or even spotting anomalies in a computer network. It makes the whole process faster and way less dependent on a human expert having to sit there and manually tweak the settings for every single problem.
Really, what DenMune represents is a major step forward in our ability to automate the process of discovery itself. It lets the machine do the heavy lifting of sorting through the mess so we can focus our brainpower on understanding the meaningful patterns it finds.
And that kind of leaves us with a final big question. We are creating data at an absolutely explosive rate. So, with smarter tools like DenMune that can let us see the hidden structures we were totally blind to before, what critical insights are we about to uncover next?